Alright guys, today we are talking about 1.4, which is all about solving absolute value equations. It's going to be a little bit different than the first three sections of this chapter. Obviously we're introducing this new type of equation. The good news is that we're still using those same inverse operations and methods to isolate our variable once we get through that kind of new aspect of absolute values. Before we get into actually solving with absolute values, just want to go through some core concepts real quick. Remind ourselves of what absolute value means, and then some different characteristics that allow us to solve those equations. So you probably know absolute value as just taking whatever my original number inside the absolute value was and making sure that's positive. So the absolute value of -6 would be positive 6. The actual mathematical definition of what an absolute value is it a function that gives the distance away from 0 on the number line. So if I looked at -6 again on the number line, that is 6 units away from 0, which means that the absolute value of -6 is still 6. So that's just the big definition and the difference between what you might understand it as and what the actual mathematical definition is. What we need to take away from that, since it is a distance, and you know as it's always going to be the positive version of that, is that anytime we take an absolute value, our answer is always going to be 0 or bigger, so greater than or equal to 0. What this translates to us is that we can never have a negative for an absolute value. It's always going to be positive. Now, getting into an actual absolute value with some variables thrown in there, if I'm taking the absolute value of an x value, and I know that that's equal to 6, the obvious answer here for what x could be equal to is it could be just 6. The absolute value of 6 is just 6. But like we talked about before, we also have this other possibility where if I let my x value be -6, when I run that through my absolute value, I also get positive 6. So that process that we're doing there, we're going to be getting two solutions for most of our problems that we're dealing with for absolute values. So we have to just make sure we account for both of those two options. Because if we can get what's inside my absolute value equal to what it's already equal to, that's going to work. But I also have the option where, like for example this last one, if I'm just saying any generic ax plus b, if I get it equal to c, that's obvious. But I could also have it where if ax plus b ends up being equal to the opposite of c, so -c, when I run it through my absolute value, I'll still end up both the same spot. So those are where we get our two different solutions from in these problems. So box 2, let's go ahead and take a look. For number 1, box 2, where box 2 is just solving simple absolute value equations. How that looks is that I'm going to split it off into my two separate miniature equations. This tells me that if I can figure out x plus 6 equal to 11, that'll give me one of my solutions, and x plus 6 equal to -11, that'll give me my other solution. So as I go through this, once I have them split, it's two totally separate problems. You're going to go through and solve each of those equations to get each of your solutions. So in this left one, x plus 6 equal to 11, just like we had in the beginning part of this chapter, I would subtract 6 on both sides to isolate my x. 11 minus 6 is 5, and 5 is my first solution here. On the right-hand side, x plus 6 equals -11. I'm still going to subtract 6 on both sides, and I get -17, because -11 minus an additional 6 would be -17. So you get two solutions. Number 2 looks pretty similar. I would take and split this absolute value off and set it equal to -3 and +3 if I was doing that opposites rule. But here with absolute value you have to pay attention. My absolute value is set equal to a negative number, which we already talked about is not possible. So if you see something like this where your absolute value is set equal to a negative, you get to skip the problem completely as long as you can remember that it's no solution. You just write that NS there. to get no solution. Number 3 is a little bit more complicated because we can see on the left side of my equation I have not only my absolute value, but I have also minus 9, and that's equal to negative 3. Now, seeing that again, I want to just jump right to that conclusion of, well, I have an absolute value equal to a negative number, so it should be no solution. But that's only an option if your absolute value is by itself on one side of the equation. So what I have to do here is kind of a step first. I'm going to go ahead and add 9 on both sides to get my absolute value of 3x minus 6 all by itself. And what I end up with happens to be a positive number. So this is actually a problem that we can find a solution to. So from here, just like I had with all the other problems, I'm going to split this off into 2 separate equations. On the left-hand side, 3x minus 6 equals 6. And on the right-hand side, 3x minus 6 equals negative 6. So solve them separately. The steps are going to look very similar for both of them. It's just what the actual solution is that will be different. So with the left-hand side, I'm going to add 6 on both sides. Gives me 3x equals 12. On the right-hand side, I'm going to add 6 on both sides, and I end up with 3x equals 0. So when I do this last step of dividing by my coefficient, which is 3, on both the left-hand equation and the right-hand equation, I get x equals 4 for one solution, and x equals 0 for the other. All right, moving along. Box 3 gets to be quite a bit more complicated because, as you can see, we're focusing on ones where both sides of my equation have an inequality or have an absolute value in them. And the way that you handle this is still the same as what we did above. It's just that here, when I split them off into my 2 separate equations, you'll choose one of those absolute values to stay the same in both of them. I usually choose the left-hand one or the more complicated, complex one. So in this case, I'm going to still have ax plus b equal to the other side, cx plus d. But when you go to the other side, I do still have to flip the sign of one of those 2 sides of my absolute value. And in this case, if I'm going to flip the sign of cx plus d, I have to be careful with that and not just change the cx, but I have to change both of those. I have to change the whole parenthesis, the sign of that thing. So some of them are a little bit more simple. If you take a look at number 4, you can see the left-hand side is 3m minus 4 in my absolute value. The right-hand side is m. So to me, it's obvious that when I go through and do my splits and set it up into my 2 separate equations, the 3m minus 4 is the thing that I'm going to keep the same. And the m on the right-hand side is the thing that I'm going to switch signs for. Because here it's very easy to switch the sign from just m to negative m. So that's the one I'm going to choose to flip-flop. And now I'm just going to go through and solve like we always have. I'm going to get my variables together. Here I'm going to subtract 3m from both sides. And that gives me negative 4 equals negative 2m. Here on the right-hand side, I subtract 3m from both sides, and I get negative 4 equals negative 4m. And so then, getting rid of my coefficient, which is negative 2 on the left-hand side, I get 2 equals m, because negative 4 divided by negative 2 is positive 2. And then my other equation, I divide by negative 4 on both sides and get positive 1 for my other m value. So positive 1 and positive 2. Number 5 is a little bit more complicated, and this is where kind of the complexity doesn't matter because they're both about the same on either side. So it's up to you on which one you keep and which one you flip-flop. So here, just for the sake of continuity, I'm going to keep the left-hand side the same. 4x minus 10 equals, Here I'm going to keep my 3x plus 1 the same. And then on the right-hand side, 4x minus 10 equals negative, parenthesis, 3x plus 1. So on that right-hand side, I'm going to go ahead and simplify right away. 4x minus 10 ends up being equal to negative 3x minus 1 as I distribute that negative into both of those terms inside my parenthesis. But once that part is done, it's just like every other problem we've seen so far. I'm going to get my variable together. So here I'm going to subtract 3x on both sides. That gives me x minus 10 equals 1. On the right-hand side, if I add 3x on both sides, that gives me 7x minus 10 equals negative 1. So now, as I continue, on the left-hand side, I add 10 on both sides to get that x is 11 for one of my two options. On the right-hand side, I add 10 on both sides, and I get 7x equals 9. So I end up with a fraction in this case, because when I divide by 7, 9 divided by 7 is not a fraction that reduces, it's not a whole number, and I can just leave it like that. If you're a decimal person, you can put it as a decimal. If you're a mixed number person, you can say 1 and 2/7 if you want to get fancy with it. I always just leave mine as an improper fraction. I have no issue with you doing that as well. So those are your two solutions. Now with that more complex solving process with our absolute values, we do have another special case. So now we looked at special cases in the last section with variables on both sides, where we had the possibility of having no solution versus infinitely many solutions. With an absolute value, we have this other new type of solution that we call extraneous solutions. And just like it sounds, extraneous, the first 5 letters are extra, and that is literally what an extraneous solution is. It's a solution that we get in the solving process that is an extra solution. It's not a real solution to our inequality, or sorry, our absolute value, because of where that variable lies. So definition-wise, you can see what it says. It's an apparent solution that has to be rejected because it doesn't satisfy the original equation. These, just like with our infinitely many and our no solution problems, you're not going to be able to identify those right away. It's something that you see as you're checking your solution. So for number 6, if I start this the same way I started the previous problems, I'm going to go ahead and do my splits, get my two separate sets of equations. So here, if I can set my absolute value equal to 4x, that's my left-hand side, and then inside my absolute value equal to the opposite of 4x, so negative 4x, that's going to be my other solution. Solving that involves getting my x's together. So here on both of those, I'm going to subtract 2x from both sides just to get my x's together in one step. That gives me 12 equals 2x, and 12 equals negative 6x. Now I just divide by my coefficient. 6 equals x, and here divide by my coefficient of negative 6, and I get negative 2 is my other x value. Now it looks like there's no issue, right? We get two relatively normal numbers, but if we were to take and plug those values back in to our equation, both of them theoretically should work. Our issue is from this guy right here. If we plug in that negative 2 into our equation, we can see pretty quickly that as we plug that in, the right side of our equation is going to be a negative 8. So regardless of what that absolute value equates out to, I have an absolute value equal to a negative number. And this is the one that gives us that extraneous solution. It is an extraneous solution. So -2 is not an actual solution to our equation, because when I plug it back in, it gives me an absolute value equal to a negative number. So the only actual solution to this problem is +6. And that is one thing for extraneous solutions that you can kind of key in on. The only time we have an extraneous solution is if the one side of our equation is a variable term and you end up with a negative number. That's the only way that you can get an extraneous solution. If both sides are absolute values, if one side is an absolute value and the other side is just a number, that's not even possible. Again, it's only possible because that right side of my equation had a variable in it and I got a negative number for a solution. So that's all I got for you today. That's it for box 4, and that's it for 1.4, solving absolute value equations. Homework is down there at the bottom. It's page 32, 12 through 24, and 36 through 44 evens. So just the evens on both of those sets. So 12 through 24 evens and 36 through 44 evens. As always, make sure you guys have any questions written down and ready to go. If you want to take a little shot at the homework to get working on that before class tomorrow, then just make sure you guys are doing that and circle any questions you guys have so we can have nice, productive class period tomorrow. Have a fantastic day, and I'll see you guys tomorrow.